Good afternoon and good morning, everyone. My name's Gemma Stevenson. Thank you for joining our webinar today, which will focus on the newly launched product carbon footprint calculation tool for lubricants and other specialties. I'm delighted to be joined by some exceptional speakers who I will introduce to you now. So with us, we have Matthew Evans, Martin Manakovsky, Christos Karavassalis, and Michael Ryan. We're also joined by Inga Herman and Mika Ketchinen for the question and answers portion of the webinar. So after the presentation, I'll ask them to put their cameras on and we can all join together to answer your questions. I'd quickly like to cover some housekeeping points to bear in mind. So firstly, this webinar is being hosted and recorded by the UEIL Secretariat. Should you not wish to be recorded, then please opt out from participating. So for example, in the Q&A, if you choose to submit a question, then your name will be visible to others. Your microphone and camera functionality has been switched off automatically. The webinar duration will be an hour. We're aiming for around 30 minutes of presentation content, followed by the Q&A session at the end. In the Q&A session, we really encourage you to ask your questions. So please do this using the Q&A button that should be at the top of your screen. This will open the Q&A function, so you can see the icon highlighted there. One really cool thing about this is that you can like questions that have been posted. So at the end, if I see that there's a question with a particular high number of likes, then I can prioritize these and put these to the presenter panel at the end. We also have a chat function, and we ask you if you have any technical issues. This is being monitored by the Secretariat and Elisa. If you have any issues, please pop them there, but please use the Q&A tool for questions. So with that, it gives me great pleasure to hand over to Matthew to begin.
Great, thanks, Gemma. As introduced, my name is Matthew Evans, and I'll be taking you through a few introductory slides that has been prepared by the team and I, just to set the scene before we take a closer look at the PCF calculation tool itself. So in that, today's session is split into three main parts. So first off, we're just going to have a quick recap, refresher of the methodology itself, why that's come about, and in turn why we have created a calculation tool. Then we're going to look at the calculation tool itself. For that, we've created three short, concise videos which look at each of the main sections of the tool, that being raw materials and emissions, as well as the associated impacts such as logistics and packaging. Then we're going to look at manufacturing and all of the activities related to that also are part of the PCF. And then finally, we're going to look at what we call the output tab, where the results are auto-populated based on the data which has been input previously. And finally, as Gemma said at the end, we should have a good amount of time left for a Q&A. So to get started, with this topic, this tends to be the three whys. So why calculate and share a PCF? So first off, there's some companies within the EU which want to comply with particular EU Green Deal initiatives. To do that, this data is required. But then on top of that, there's a number of reasons. It may be that you or your customers want to take accountability for your impacts or impacts of the products, and in turn you want to make informed choices. Or it could be that you want to compare your PCF of one product to another, or simply that you want to try and find hotspots within the PCF. So for instance, you could look at particular raw materials or certain transport links and things like that. So after this, why a sector-specific methodology? So prior to the ATIEL UEIL joint PCF methodology, which was released in November 2023, the main standards available were ISO 14067, as well as the Greenhouse Gas Product Protocol. Both of these methods are great, but they do provide a broad framework and with that, it can be open to interpretation. So having a sector-specific methodology looks at the process that are particular to our industry, the lubricant industry, and tries to minimize the variables involved in that so that we're all essentially doing the same thing. And this is when we talk about transparency of the PCF calculation. And then finally, why supplementary Excel-based tool? So now that we have this methodology, it's great and it's a big step forward. But then the next question is, what do you do with it? How do you use it? So we've put together what we hope is a very good practical aid. And it's a tool based off the methodology with step-by-step user instructions throughout. So building on that slightly, the joint methodology, the ATIEL UEIL, at its core is based on ISO 14067 and the Greenhouse Gas Protocol. But as we say, it's industry specific. So all of the nomenclature and the nuances within our industry is throughout the methodology. And we feel much easier to read and understand and then put into action to actually calculate a PCF for yourself. And as of last year, the ATIEL UEIL methodology has been certified by TÜV Rheinland. So thinking about goals, the main goal, as mentioned in the previous slide, is to harmonize PCF calculations. Can we all do this in the same way? And in that, achieve alignment within the lubricant industry. And when we think about intended audience, it's not just for lubricant manufacturers, but it's also for internal, external stakeholders. It could be for auditors, practitioners. So there's a wide range. So like we say, the tool is based on the methodology. So the output of the tool is to create a PCF for 1 kilogram of unpacked lubricant or specialty fluid. And this is a boundary of cradle to gate. So cradle being everything from raw material extraction and manufacturing through the transportation and the related upstream emissions, such as transportation and packaging, and then all of the activities related within the manufacturing step up into the outbound manufacturer's gate. So within the UEIL ATIEL method, one thing which we feel would very much help you in creating a PCF is that we've put together a stereotypical production process of a lubricant manufacturer. So I think as with any PCF calculation, it relies on data collection. So knowing what data you need to collect and where that fits into the model is always a good start. And it's split into the two systems, as they call it, the foreground system and the background system. So the foreground system is everything that the lubricant manufacturer is directly responsible for, and the background system is everything that sits outside that, everything that's out of indirect control. And this is a good example of an industry-specific method. So this is directly related to what we know and understand within the industry. And when we look at the generic methods, it's not something, for example, that you would find in that. So hopefully that's jogged your memory or helped set the scene. So now we're going to have a closer look at the PCF calculation tool itself. So when you open the tool, it's an Excel-based tool. You're met with 4 main tabs across the bottom. So the first one on the far left is the guidance and how to use section. So this gives an overview of what's involved, how things are structured, what to look out for, and things like that. That then moves on to the right of raw material impacts, which also includes transportation and packaging. That then moves on to manufacturing and all of the activities within that. And finally, once the data has been input into the relevant cells, your PCF is automatically calculated on the output tab. So again, transparency pops up again. We hope this helps create consistent results. And it's very much step-by-step guide, what to do, and also we hope some helpful hints and tips of where to look, how to get information, that type of thing. So like I say, the first page I met with on the tool is the the how to use guide. So just for sake of formality, if I could please just read the disclaimer. The product carbon footprint calculation tool is co-owned by UEIL and ATIEL. Neither UEIL nor ATIEL assume any responsibility for the use of the product carbon footprint calculation tool that is made by lubricant industry stakeholders. UEIL and ATIEL cannot be held liable for the correctness of the results generated by using the product carbon footprint calculation tool and the use of the results by lubricant industry stakeholders. So that's just a more formal nod towards we've put this together as a joint task force to the best of our abilities, off the back of the methodology. But we would always recommend, if you want to externally use your results, to get your PCF data externally certified by a third party. So I think now we're going to go into the videos themselves, looking at each section turn by turn. I should just note at this point that there is special emphasis has been put throughout for SMEs, so to where you may not have as many resources or knowledge of this area. This is where we hope that all of the step-by-step instructions and the notes around the calculations will come in useful.
Thank you, Matt. Thanks for the really great introduction and context into the PCF calculation tool and why and how it was developed. So as Matt said, we're now going to play for you 3 demonstration videos showing the PCF tool in action. And we've also got some voiceovers on these videos to guide you through using the tool and each individual tab. So as Matt mentioned, when you first open it, you have a guidance on how to use tab, and we strongly urge you to read this before going on to use each of the individual tabs. The first video, we're going to look into detail as to how to use the raw material emissions input tab. So I'll play this video for you now.
Now, we will dive a bit deeper into the input tabs, starting with the Input_Raw Material Emissions tab. The tab consists of 4 different parts. First, you can find a detailed user instruction on top of the tab, which guides you step by step through all relevant input cells below. The input cells are divided by 3 different colors. In the yellow part, the raw material related upstream emissions will be calculated. At first, you need to fill in all raw material related information in the respective cells, starting from the supplier and raw material name, the treat rate in %, the sum of PCF, and finally you can make use of the data source column for a qualitative assessment of the data quality besides more transparency on the used input data. Please note that the aim of this tool is to provide a user-friendly tool, and thus, a quantitative calculation of the data quality rating is not included so far. In the yellow highlighted cells next to the data source, the impact of each raw material based on the treat rate is calculated and summed up. If you require more lines, you can use the expand and collapse function. In case you do have more information available, such as the 3 summands, partial, PCF fossil, biogenic, DLUC, or the carbon content information, biogenic, total and recycled, or the remaining GHG emissions, you can make use of the expand and collapse function as well to unhide those input cells. The impact on the product level will be calculated analog to the sum of partial PCF. If you use partial PCF values for your raw material, which are calculated cradle to manufacturer inbound gate, then you are already done for this part. However, if you only have cradle to supplier outbound gate, excluding upstream logistic and packaging, you can make use of the orange and blue part, respectively. In case you have different supplier for one raw material, we recommend either a mass-based pre-allocation or to use multiple lines in the template for the same raw material, adjusting the RM treat rate according to the mass-based supplier share. In the orange part, you will be first asked if the upstream logistic, meaning the emissions caused by the transport between the supplier and lubricant manufacturer, is already included in the partial PCF of the raw material. If yes, this part will get blackened out. If the upstream related logic emissions are not already included, you have mainly two options. 1. Your supplier already calculated the emissions caused by the upstream logistic in CO2 equivalents. Then you need to use the drop-down function No, but emissions calculated, and enter the value in the column next to it. 2. If you don't have those emissions available, you need to enter the distance between the supplier and lubricant manufacturer plant and the emission factor for the main transportation mode in kilograms CO2 equivalents per ton kilometer. Finally, you have, like in the yellow part, the opportunity to enter a data source for a qualitative assessment. Via the expand and collapse function, you have again the opportunity to enter more detailed information, such as the summands of the emission factor for fossil, biogenic, and DLUC emissions or more transportation modes, if available. In the blue part, you will need to enter the emissions caused by the upstream packaging between the supplier outbound and lubricant manufacturer inbound gate. The first question is analog to the upstream logistic. Are the emissions already included in the sum of partial PCF of the raw material? If yes, everything gets blackened out. If not, you have again the same two options as for the upstream logistics. 1. If the emissions allocated to 1 kilogram raw material are already calculated, you can enter it in the column next to it. 2. If you don't have any information, you need to enter the weight of the main packaging normalized on 1 kilogram of raw material, e.g. if you have a 15 kilograms drum, empty weight, in which 20 kilograms raw material is stored, then you need to divide 15 kilograms per 20 kilograms to obtain the specific weight, and the emission factor for the main packaging material. Then, the emissions will be calculated automatically. Finally, you have, like in the yellow and orange part, the opportunity to enter a data source for a qualitative assessment. Via the expand and collapse function, you have again the opportunity to enter more detailed information, such as the summands of the emission factor for fossil, biogenic, and DLUC emissions or more packaging types, if available. In the end, all calculated emissions will be transferred to the output_PCF calculation tab, which will be explained later in more detail.
Okay, so that was the first video, the first input tab video on raw materials. I've just checked the Q&A function and there aren't any questions coming in specific to the raw materials tab. But I will take this opportunity just to encourage you to submit any questions using the Q&A function, and we'll take the general questions at the end. So the second video, which I'll play for you now, showcases the manufacturing emissions input tab.
After the calculation of raw material emissions, users must calculate emissions of lubricant manufacturing activity. This is done in Input Manufacturing Emissions sheet. In this sheet, cells holding calculating formulas are locked. So, users shouldn't be afraid to work. Users are guided step by step through data input requirements. They are prompted to read PCF methodology for system boundary, allocation, waste generation, etc. The activities stated are quite common within the industry. These can be adjusted accordingly. The process flow chart at the bottom of the sheet shows the operations of a typical lubricant manufacturer. The foreground system shows the activities that need to be considered by the users. Users should consider allocation for the process. For example, use of average figures or data directly related to the product in question. Basis of calculations is always 1 kilogram of product. The results are collected in this table, as users complete the templates below. First, users must calculate energy emissions from their utilities. There are several options of energy consumed, but still, users may add their specific form of energy by expanding the table. Users must put the period, the unit and the quantity of consumed energy. Here for example, 10,000 kilowatt-hours. The quantity of blended product, let's say 50,000 kilograms. The tool calculates 0.2 kilowatt-hours per kilogram of product. Here, users should put the emission factors. Total kilograms of carbon dioxide equivalent per kilowatt-hour consumed. Well-to-tank upstream emissions. And the data source for each emission factor. So, the tool calculates direct, indirect and total emissions per kilogram of product for this energy consumed. Electricity may be location or market-based, and users can use specific conversion factors. Next step is to calculate emissions related to wastes generated through manufacturing. There are 3 predefined wastes and users can expand the table and add more. Users can determine whether an investigated waste must be included into PCF calculations. For this, there is a decision tree at the end of the sheet, according to methodology. Again, users must put the period, the unit and the quantity of managed waste. Here for example, 5 cubic meters. And of course, the quantity of related product, in kilograms. Here, the users put the emission factor per unit of waste. Well-to-tank factor is not applicable in case of wastes. Once every cell is filled, the tool calculates the total emissions per kilogram of product related to this waste treatment. Finally, both energy-related emissions as well as waste-related are collected to the table at the top of the sheet. Total value is transferred to output sheet.
So that was the second video on input tabs. So once the 2 input tabs have been filled out with the correct information in the correct cells, the output tab can then be viewed. So this next and final video demonstration will make clear what can be seen in terms of outputs and what can be learned in terms of the results of the PCF calculation.
Now we change to the output PCF calculation table. The calculation is almost done. You have just to provide some additional information and your report is completed. At the head of the table you find some additional information about the reporting requirements and about the data quality. Although the ATIEL/UEIL methodology includes lubricant manufacturers as well as their suppliers, this application tool focuses mainly on lubricant manufacturer. The reporting requirements for suppliers may be different in some aspects. We prioritize user-friendliness of this application tool. Therefore, data quality factors are fixed to 3 as a default value to reduce the complexity of the calculation. Every user may override this value if they have additional information, but the calculation itself is not included in this tool. At the beginning, you should fill out some basic information about your company and the product. The company name, in this example Company Blue Sky. The product trade name and the article code, for example Product Lubricant Excellence / article code 1,123,344. And the date of your calculation. Our gray fields are already pre-filled, and additional input is not necessary for these fields. The yellow fields are the most important ones. Here you will find the calculated product carbon footprint of your product. The values are automatically calculated by the tool. Also for these fields no input is required. The calculation is based on the values entered in the raw material and production tabs. With the plus and minus you can expand or collapse the table even further, and you will find additional information of the calculation, provided you have entered the data in the corresponding tables. From our experience, the necessary input data are rarely available, and for this reason these fields remain for many calculations collapsed. Finally, you have to enter some last information to complete the report. If you have made cut-offs during your calculation, please enter the criteria and the cut-off. Please note that according to the methodology, the sum of all cut-offs must be below 5% of the PCF. Please enter the selected allocation. For lubricants, an allocation according to physical relations formulation would be typical. This means, for example, you have a formulation of 5 raw materials and specific concentrations, and every raw material contributes accordingly to the PCF of your final lubricant. You can find the decision tree for the allocation type on the right-hand side. This is a simplified reporting field. In practice, it is possible to use different allocation types for the different activities. We are coming to the final steps. Please enter also the other required information, such as the time period for which your calculation is valid or a short technological description of your product. And now, you are ready to print out your final report.
So that now brings us to the end of the 3 demonstration videos, showing how the 3 tabs within the PCF calculation tool can be utilized to achieve values that can be shared with other stakeholders. And hopefully you've now got a nice flavour of what can be achieved through the use of this simple, really user-friendly tool, which we'll encourage you to download and use. So I've just popped on the screen there where you can find that document, where it's located. So there's going to be step-by-step guidance provided within the tool itself to really help the user generate meaningful, relevant and consistent results. And we'll also make both this webinar available, and we're looking to develop instruction videos in English, French and German. As mentioned previously by Matt earlier on, the tool has been developed in line with and to facilitate the use of the ATIEL and UEIL methodology for PCF calculations for lubricants, greases and other specialties. The methodology document can also be downloaded using the links you can see on the screen now. On the web pages, there's also a link to a webinar recording from last year presented by ATIEL and UEIL, which gives an in-depth look at this methodology. As we've mentioned, we'll be creating the instruction videos, making the webinar available. But if now at the end of this webinar and as you begin to familiarise yourself with the calculation tool, if you've got any further questions, comments or feedback, then please don't hesitate to get in touch with us at secretariat@ueil.org. Your thoughts and opinions will be very, very welcome. So what I'll do is I'll pop these links back up onto the screen towards the end as well. But what I'd like to do now is to ask the presenters, so Matt, Martin, Michael, and also Inga and Mika to come onto screen so we can begin the Q&A. And I've noticed that we've had quite a couple of questions coming in as we've been playing the videos and presenting. The first one I noticed coming in was right at the very beginning. And what I might do is put this to Michael, and Matt, if you've got any builds, please feel free to jump in. Is it possible to group several similar products under the same average PCF? And what would the rules be for this? And I think the driver for that question would be that it would make much simpler the calculations for a full product portfolio.
Yes, this is a very good question. So in general, the tool is aimed for a single product calculation because this should be, let's say, the most accurate level of calculation. In the end, if you decide to use a kind of a weighted or average PCF value for a certain product group, then you also need to allocate all the input data accordingly. And after doing this, we definitely highly recommend to perform a third-party review for external communication of those results. Yeah, so this would be, let's say, a general question. Hope this answered. And if you have any follow-up questions, post them. We can take up.
Matt, anything to add there?
I agree with what Michael just said, and just one small addition, and maybe for ease of use. Once you start populating the the tool, you could simply copy and paste across certain raw materials or activities, which might speed up the process.
Brilliant, thank you. And Matt, whilst I've got you off mute, and we're talking about ease of use, can we use this tool if we don't have any previous experience with calculating PCF?
Yeah, so that's the goal of the tool was to provide step-by-step user instructions for almost someone who's brand new to the topic. So there's, as well as the instructions, there's a lot of the cells have pop-outs that give definitions or helpful hints of where to look. And again, this was with SMEs in mind who may not have the resources or the teams behind this, and maybe a learning curve for the user as they work through it.
Brilliant, thank you. Michael, I'm going to come to you again because we've had another question on raw materials, but in this case, the use of recycled raw materials. Where we have these materials, what should be included in the partial PCF in the input tab?
In general, you can see recycled raw materials similar to virgin raw materials from the treatment of a PCF calculation. So in the end, you need to enter the PCF value, and if you have available also the summons for the fossil part, the biogenic, and the direct land use change part. The benefit of the recycled raw materials should be displayed in the PCF value itself. So we assume that the recycled raw material will have a lower product carbon footprint than a virgin one, because as also described in our methodology for the end-of-life treatment of recycled material, we follow the cutoff approach. So therefore, let's say if they're entering the second life cycle, they are free of burden. So therefore, the PCF value while entering in the second life is 0. So therefore, we see there, or we would at least think that there should be a benefit in the PCF value if calculated accordingly.
Okay, great. Sorry, just to keep you off mute, you mentioned there about the entering all of the individual summons. What about if a user only has one PCF value for the raw materials and not all of these individual contributions, so from the fossil part, etc.? What happens there if they've only got that one value?
As already mentioned by Matt several times, the major goal was for SMEs to get started with PCF calculation. So therefore, we designed this tool also in a way that if you only have a single value, you're still able to calculate a PCF result. This is why we introduced these expand and collapse functions, because they enable you, if you have additional information, you can enter them as well. And then you are following the UEIL methodology. But in the simplified version, you're still able to calculate, but you need to be aware of that you're not fulfilling all the reporting requirements according to our methodology.
Brilliant, thank you. I've seen a couple of questions coming in, and Matt, I might come to you first, and then Inga and Mika, we can maybe build on this. Has this tool been verified, and are the results of the PCF calculation using the tool verified according to the ATIEL and UEIL methodology, which obviously has that TÜV Rheinland certification attached to it? So, and I think the specific question from the audience was, how can suppliers communicate that they've got a footprint based on this methodology, and how can users be sure of the correctness?
Yeah, so the tool itself isn't certified, which is when we refer to the third-party certification. However, the methodology has been certified by TÜV Rheinland. So for this, with suppliers, for instance, you could ask for data in line with the methodology, and then the tool comes in as almost a supplementary aid, a practical aid, as we say, something to help you convert this raw data into the actual PCF itself.
Brilliant, thank you.
Hey, maybe could I add just
Go for it.
One point over that? I think that's all exactly so. Maybe to emphasize that I think the methodology does give some strong recommendation on certifying your results, and there's the guideline also in the ISO that is the underlying standard there. we endorse to you to actually certify the results, the implementation of the methodology and the results, and that will also look at the data sources, and hence that will put you on the safe side there.
Fantastic. Thank you, Mika. We're seeing questions coming in now about when we don't have information available from suppliers, and if they don't have that data available, where can we find accurate and representative data without having to pay for it? And I guess there's a question there, Inga, on what databases can we use? What's available out there for users to make use of?
Yeah, thank you for the question. So overall, there is to say that there are several databases available. So the options for the lubricant industry remain somehow limited. So commercial databases like EcoInvent or Sphera or Carbamines are widely used to their standardized and transparent data and the consistent methodologies. For example, Carbamines offers data according to the ATIEL UEIL methodology if you specifically ask for them, besides, for example, TFS, Together for Sustainability. But some even provide regional data sets, which are valuable for location-specific analysis. And however, a major challenge is that few databases include the detailed data required for lubricants, and updates can be inconsistent. So public data sources like GEMIS or DFRA are also accessible, but they primarily focus on energy or specific regions and often lack the necessary level of detail for lubricants. So there are data sets, sorry, just to add a few words. If there are no data sets available or even not available in the public databases, there could also be used proxy data or estimates by best guess of experts, for example, or literature.
Fantastic. Thank you. That's super, super helpful. Michael, I'm going to come to you now, and then Mika, potentially you can add on to this. We've had a question on whether there are standard templates available in terms of requesting information from suppliers, and what do we do if the information that we get from suppliers doesn't match up with what's required from the tool? And then perhaps further, are there any plans for the Joint Sustainability Committee to reach out and provide industry data?
Yeah, for now we can say that we didn't focus and have it on the agenda to provide such a template, so supplier request template. We can tackle this offline again and discuss this further, but for now it's not foreseen. What I can add on the part, I think there was a question regarding the PCF reduction values shared by any suppliers, for instance, from re-refined base oils. You cannot convert those information directly into the sheet, and you definitely need PCF values to also calculate your PCF values. So therefore, we highly recommend to reach out again to the supplier, because if they kind of calculate a PCF reduction, this means that they can also calculate a PCF value. So therefore, I would propose to ask for the real value, then can enter into the format. And coming back to the initial question, if we only have some data available, this is also again why we decided to make a very simplified template, because you at least need one data point, and this is the PCF of a raw material. And this should be available for a supplier if they can calculate a PCF value. So either they have no PCF value available, or they have at least one value for the sum of PCF. And then with this information, you are already able to calculate according to the tool. So yes, I think there is no one-fits-all solution, but this is what I can say for the state of the art.
Yeah, I think just to add to that, the you wouldn't be on your own, or it'd be very unlikely if you had all of the data. So quite often you do find data gaps, and this is where the secondary databases can come in handy for filling in the gaps until you have the primary information available. And this is where the tool is great, because it can almost get you started, see what you need, and maybe identify some hotspots earlier on, or give you an idea of what the impact is of the product. But unfortunately, data gaps is in most cases, or a lot of cases, inevitable at this stage.
Yeah.
Yeah, maybe I just want to confirm really from my end. The important thing is to get everybody started. I mean, you have, from my perspective, you have the methodology. This is more or less the framework. With the certificate, you know that the settings are more or less correctly, and using the tool, it's easy to get a start at least. And this is really the aim of the tool.
Yeah, great point.
Yeah.
Mika, did you have anything to add?
Yeah, I mean, following up on the previous speakers, I think it's evident that, several, different type of sources, data sources, different levels of them, still gaps in that. It's evident we do see that, yeah, generating data and selecting data sources really are crucial steps in harmonizing PCF calculations. But as said, really only the producers can control the data on the emissions from producing components and products, and hence to refer to your end part of your question on whether we are working on like certain industry data, generalized industry data. So the answer to that therefore is no, not at the moment. But because of all this and the importance of that, ATIEL and UEIL really through the Joint Sustainability Committee and the work groups there, we've actively worked to try to address any potential data gaps. And one example I would maybe say here on this side is the work that the European Union started under the Product Environmental Footprint Framework Revision, the LCI database initiative, and there we have collaborated with Carbon Mines, who's leading the work package for chemicals in that. And in this collaboration, we were helping with data sets that are tailored to the lubricants industry. And now in the agreed scope include data for critical raw materials like group 1, 2, 3 base oils, polyalpha olefins, as well as re-refined base oils, and also data sets for manufacturing processes for production of lubricants and greases.
Yeah, I think the data quality will evolve over the time, and especially as companies need to start calculating data. I think it's a journey, and I think the data quality with that will definitely getting better, as everyone has to start somehow. Even there is no mandatory request of providing PCFs, but I think we will get pushed by the legislation, by the regulation, and not just by the stakeholders. So therefore, I expect pretty much that we will face a better data quality somehow in the next years.
Great point. Thank you, Inga. Mika, I just want to come back to something you said on data gaps, and I'll just open this question out to all of you. And we heard a similar one in this morning's webinar. Could this tool be utilized in adjacent markets, for example, brake fluids or paints, for example? Do you see it having applicability there, or being adapted or built upon?
Well, I think I let the tool expert start this answer.
Yeah, maybe
yeah, go ahead, Martin, please. Sorry.
Okay, I can take this question. I would expect, if I'm looking for paint, something like this, it is a similar chemistry. It's they're dealing with mixtures, and in general, it should be possible to use the tool to calculate also the PCF values for paints. If there are specific requirements or regulations, they have to be considered, that's clear. But in general, it should be possible to use the tool as well for others, also for glues and other mixtures.
I think that's a great summary. Thanks, Martin.
But hey, Gemma, sorry, may I
jump in, mate? No,
continue
Do it, Mika, go ahead.
On that, since you mentioned the adjacent industries, and I think that's important point for, you know, for our whole efforts in harmonizing the LCA and product carbon footprint in the value chain, is that you really need to cooperate with the, you know, stakeholders in the adjacent sectors before and after your position in the value chain, and that's important work what we would emphasize, and by, you know, drafting methodologies, making tools, and then making sure and collaborating with the adjacent industries that we could get them endorsed and harmonized in a sense that they would be compatible. So I think that's important work item for us.
Great point. Thank you. Matt, if I could come to you with this next question involving well-to-tank and how to use it in the manufacturing emissions tab. For example, for the use of bioenergy, should this include or exclude any biogenic carbon credit?
So with well-to-tank, so there's the upstream scope 3 impacts in line with the method have to be included. So within the raw material tab, for example, you have transportation. With transportation, you would have a main conversion factor, and then separately you would have what they call the WTT factor, the well-to-tank. And this is all of the indirect impacts associated with that main impact that's being calculated. And then I think for the biogenic is almost a separate question. Michael, you may be better suited to answer this one.
I mean, in general, you can, for the manufacturing part, I think you have the opportunity to also add on individual lines or emission factors. So therefore, I think it's more a question of market-based and location-based, right? So for the bioenergy source, I mean, we think that you see a difference in the well-to-tank factor there as well. So I'm not sure what the aim of this question really is, but including excluding any biogenic carbon credit for the well-to-tank factor is also something. If you follow up on the methodology, we follow the characterization factor of -1 + 1. So we would also assume this for the energy sector. So therefore, we would believe that if the supplier calculated accordingly to our methodology, also for the WTT factor, then you should see there a kind of a credit, I believe. But yeah.
Brilliant. I think that's clear. I'm just scrolling back down to the bottom because we're having quite a few questions come in and I've missed one. Martin, if I could potentially put this one to you, if that's okay. So when we're thinking about raw material treat rates, do the percentages add up to, do they have to add up to 100% to be thorough?
Mm-hmm. Yeah, thank you. So this question relates also to cutoffs. If it's not possible that I have the data for all the raw materials, then I can try to apply cutoffs. The only thing I have to do, I have to follow the rules for the cutoff criteria, and the general rule here is the maximum cutoff is 5%. And this is true for everything, for the mass flows, for the energy flows, or also for the emissions. So the tool is working even if you don't have 100% formulation in the input sheet for the raw materials. Yeah, it works. In the output sheet, you have then the opportunity to give the gap in the field for the cutoffs.
Brilliant, thank you, Martin. And just whilst I've got you here, I had a question, and it was related to when we were thinking about the energy inputs in the manufacturing emissions tab. What if people can't measure their energy input of the products blends that they're making? Like, what would the user do if they can't get that information? Please feel free to jump in, Matt. Anybody?
I can take a first stab at this one. So this would be an allocation question. So you look at what data you have available or how granular your data is and then expand out. So you're looking for the for manufacturing example. So you're looking for the energy used to heat 1 kilo of product while stirring, for example. It might not be that the tank, for example, has a sub-meter on, but it may be that over a given time, we use this much energy to produce this much product, which would then allow you to divide that back to the energy for 1 kilo. So yeah, like you say, it comes down to what's available for the user, which is different for almost everyone.
Yeah. And can you get that from databases? And you would obviously have to put that, you'd have to state which databases have been used for emission factors in that table.
So if you were taking this data yourself, the source of the data would be just own data. So it's self-calculated. You can, on secondary databases, you can get general figures for manufacturing in which you'd put down the source. But it would be, like you said, it would be a general figure based on location.
Okay, thank you. Thanks for answering my question.
Yeah.
Michael and Matt, this might be one for yourselves as well. So we're thinking about product carbon footprint specifically in this tool. It's called PCF calculation tool, but are there any future plans within the group to include anything on use phase or waste treatment, thinking about achieving that more full life cycle overview of a lubricant?
I can start, Matt, you can jump in afterwards. So in general, we started to focus on the cradle to gate approach because this is already really complex. As you see in the tool, there are many things you need to consider. And we focused on this scope because this is an information which should be the easiest accessible, I would say. When we are thinking about a use phase and then especially end of life, those are information which are very hardly to collect. And therefore, if we think of already gathering data from our supplier, which is hard, those data points to collect are way harder. So therefore, we, for now, stayed with a cradle to gate approach because this also enables us to exchange PCF values across the sector and across the value chain. So our cradle to gate PCF of a lubricant manufacturer is exactly what maybe our customer then need to calculate their PCF value. So let's say this is our main responsibility to provide those information. Nonetheless, the use phase and the end of life, especially for loops, has a high impact. So this is also why we are looking at a separate working group also on those use phase, and we try to kind of make any guidance or give guidance or try to include this also from a PCF perspective. But for the time being, the way focus is cradle to gate PCF value.
Brilliant, that's clear. Anything to add, Matt?
No, I would agree with that. That sounds good.
Okay, great. Well, I can put a question to you then, if you've got nothing to add. You mentioned earlier on, I think in one of your answers to one of the questions around certification, and you said have it certified by a third party. Can you explain what you meant by this? And do you recommend carrying out an inspection to verify the results that come out?
Yeah, so by this we mean that you would submit your PCF for an audit, and by third party we mean an independent third party, just for credibility. So the audit, typically the auditors you would send all of your raw data, your calculations, your reasoning across. You could send across the tool filled out along with the methodology, and they would work through that and check that it's all in line and calculated as you say so.
Yeah, no, thank you for clarifying that. We've just had a question come in as well, just thinking back to manufacturing emissions and whether we can offset electricity generated on site through solar, for example, against the manufacturing uses. So can we factor in offsetting within that manufacturing emissions tab? Don't know who wants to start on that one.
I mean, in general, you need to allocate the emissions you provide from the grid in any way. So you need to measure what you, let's say, consume from the grid. And you need to account for those emissions. If you, let's say, generate them by yourself. This is again a question of allocation and how you can measure the additional electricity. Talking about offsetting, I'm not quite sure what the main idea of this question is, how you want to offset, but in general, offsetting PCF calculation is not applicable. But yes, if you produce, let's say, green electricity through your own solar panel, this is of course, let's say, free of emission energy or electricity in this regard you can use. But if you purchase additional electricity, you definitely need to count in for those emissions. That
Brilliant.
please, Free or Martin. Yeah.
Nope, all good. We're getting nods and smiles. Thank you for that, Michael. We might have a question here that might be of interest to some people in the audience with respect to greases. So can you see any difference in a tool that would be used to calculate the PCF for a grease? Can you see it being different to what we've presented here? Michael, do you want to start on that question?
Yes, I mean, in general, the tool is for both liquid lubricants and greases. So the main difference is the emission manufacturing, so the emissions from manufacturing part, let's say. So we do see that you maybe have a higher energy demand or electricity demand for producing a grease compared to blending an oil, for instance. But in the end, the tool and what you need to calculate are the same activity data. So you need to measure the electricity consumption and the energy consumption. You need to measure the waste and so on. So therefore, you can also use this tool to calculate the PCF value of a grease. So this is also possible, yes.
Okay, perfect. Thank you. I'm just looking at time. So what I'm going to do is just pop the contact details and information about where to find the tool and download the PCF methodology document. And I think we've answered all of the questions in the chat. Please feel free to correct me if I'm wrong. There was one around how the webinar will be distributed following today. So you will get a link sent to the recording, I think, if you've registered and attended the webinar, and we will also make it available on the website. So I can tick that question off. And perhaps to finish, I've got a question noted down here about waste. So Matt, I might come to you. If I recover energy from my mineral oil waste and use this energy for my blending process, so thinking about energy recycling there, where should I calculate emissions? Is it in the first table that you showed around direct emissions, or is it in the second one with respect to wastes?
That is a good question. There is, I'm not sure if I'd like to answer that off the top of my head. There is, to give some direction, at the bottom of the manufacturing tab, there's a flow chart for waste and where emissions are allocated. It's a yes/no flow chart, which ends up with whose responsibility the emissions are. The important thing is that you capture them and capture them in the correct place. I don't know if anyone can remember off the top of their head, but that would be my first port of call.
Yeah, that's the decision tree, right, that we saw in that tab.
Yeah.
That looks super clear. So direct people to that. It's a great question to finish on, a great answer. Thank you, Matt. But just in the interest of time, I've popped the key takeaways slide up again so you can see where to download the document and the email address, the secretariat@ueil.org address. If you've got any further questions, comments or feedback, please do send them in. And I think on behalf of all of the speakers, Michael, Martin and Matt and Mika and Inga for joining us, also thanking the Secretariat and Elisa for monitoring the chat as well. I'd just like to say thank you for attending. We hope you found it useful and insightful, and encourage you to make use of the resources that this fantastic team have put together, and have a great rest of the day. So thank you very much.
Thank you.
Thank you.
Thanks all.
Thank you.